Welcome viewers, welcome to the new lesson from Dr. R's Biology. In this session we are going to learn about how can we remember easily the structure of purines and pyrimidines without any confusion and permanently storing in your brain without erasing from there. This content is more useful for competitive examinations that will be appearing after higher secondary or after post graduation. So from NEET to CSIR, UGC, NET or JRF, this session will be helpful, including PG entrance examinations that is conducted by QSET, CUSAT, etc. That also it will be useful. If you are the first visitor or if you did not subscribe my channel yet, you can just subscribe, and also you can just click on the bell button to get notification on new video uploads regarding tricks to learn biochemistry for competitive examinations. I am also seeking your help. You can also suggest the topics that is to be discussed here, and I will be just considering your suggestions. You can just comment on the comment box as your suggestion. This particular video we will be covering in these three parts. The single video which will be just having a duration of around 8 minutes, and it will be just covered to avoid three confusions while you are writing purines or pyrimidines. So three confusion is nothing but the first confusion: what are the members in purines and what are the members in pyrimidines? That is, you will be having confusion like whether guanine belongs to pyrimidine or guanine belongs to pyrimidine, whether cytosine is pyrimidine or purine. So such confusion will be there, and we will be clearing that confusion first, and we will be finding a way to remember and avoid such confusion in a better way. The second confusion that we are going to solve is nothing but whether purine contain double ring or pyrimidine contain double ring. So that is we are having always confusion in that particular aspect. So that confusion will be avoided in the second part. And third confusion that we are going to avoid is nothing but how the atoms or molecules are organized within the ring of purine or pyrimidine to form different types of purine and different types of pyrimidine. So we will also find easy tricks to remember the distribution of atoms or molecules within the ring of purine and pyrimidine. So if you are ready to clear these three confusions, you will be permanently remembering the structure and names of purine and pyrimidine perfectly. So let us see the video. So we know that purines and pyrimidines are nitrogen bases, which is one of the building blocks for nucleotides, that is in turn is the basic unit of DNA. Purines are nothing but adenine and guanine. The pyrimidines are nothing but cytosine, uracil, which is present only in RNA, and thymine, which is present only in DNA. We know the names now, but after some time we will be definitely forgetting what are the names, what are the structures, etc. So how can we remember all these 5 structures and names and categorize it into purines and pyrimidines? So how can we remember? So first, as I told you, first confusion is nothing but whether uracil is purine or pyrimidine or guanine is purine or pyrimidine. So that is the first confusion. So we can easily avoid that confusion in a simple way by remembering the following keywords. The keywords are nothing but APEC and CTP. Don't get confused. APEC stands for adenine and guanine are purines, and CTP stands for cytosine, thymine and uracil are pyrimidines. So if you are just remembering APUG and CTP, it's a simple word because CTP we are getting punishment in our school days to sit up and run. So the same word, if you are just remembering, you will be just remembering the pyrimidines. And we know the Vodafone ad pug, and if you are just remembering a pug, you can just easily remember adenine and guanine are purines. So relate these two terms in your life experience to your life experience so that you can easily remember these two keywords. So APUG stands for adenine and guanine are purines. CTP stands for cytosine, thymine and uracil are pyrimidines. Now the second confusion. Purine or pyrimidine contains two rings. You can easily remember which one contains two rings, which one contain single ring by remembering the general saying that God will not give everything to a single person. Okay, what it means? We know that the number of letter in purine is less than pyrimidine because purine contains 7 letters and the pyrimidine contains 10 letters. So, number of letters are less in purine and more in pyrimidine. Therefore, definitely something should be more in purine and something should be less in pyrimidine. So, more ring is there in purine, that is 2 ring structure is for purine, and you can see the 2 ring. So, first one and then second one, and we can see that the less, so that is a 1 is there in pyrimidine. Why? Because pyrimidine have more number of letters. So this is the single ring of pyrimidine. So that confusion is done. So is no more there. No more confusion with regard to whether purine or pyrimidine contains two rings. So purine, as the number of letter is less, the number of ring is more. Pyrimidine, as the number of letter is more, the ring is less. So pyrimidine is one ring and purine is two ring. Now coming to the third confusion. How the atoms or molecules are distributed along these two ring structures or one ring structure in purine and pyrimidine respectively. Whether uracil contain amino group or uracil contain the other deaminethylated group, etc. Or guanine contain amino or adenine contain amino on top. So such confusion can be easily avoided if you can remember the keyword. First one for purine, we will be just discussing the distribution of atoms or molecules across the pyrimidines. So in order to remember that for the pyrimidines, you have to remember the keyword cut, C-U-T, cut. So cut is nothing but C-U-T, and where C stands for cytosine, U stands for uracil, and T stands for thymine. So all this cytosine, uracil and thymine is having a basic ring structure, basic common ring structure. So that is nothing but the three that is given in the figure that you have to definitely learn. There is no way to remember that particular basic structure. We are just saying how to avoid confusion only. So basic structure you have to learn. So if you are remembering this basic structure, you can easily remember the purine basic structure also. So this is a basic structure that is common to all pyrimidines, cytosine, uracil and thymine. Now we have to remember that cytosine is undergoing a process by which it can convert it to uracil, and the uracil is in turn undergoing another process by which it will be converted to thymine. Okay, so the process that converts cytosine to uracil is nothing but deamination, and the process that converts uracil to thymine is nothing but methylation. So if deamination should happen to cytosine to convert it to uracil, the cytosine should contain an amino group. Okay, so if it should contain amino group, so amino group is there on top of the cytosine. So after this, we are just going to complete the cytosine structure. We can just cover the valency of all the atoms in the ring. So let us see this particular carbon. to which amino group is attached. We can see that only 3 valencies fulfilled, one with the nitrogen of the amino, one with the nitrogen and one with the carbon. So one valency is remaining. So what we have to do? You have to insert a double bond. Now the question is where we have to insert a double bond, on the right side or left side. Keep in mind that while filling the valency, there is two rules. First rule is nothing but you have to always move in anti-clockwise direction. So the first rule is you have to always move in anti-clockwise direction. The second rule is you have to insert double bond first, and if double bond possibility is not there, you can insert hydrogen. So second rule is you have to insert double bond first, and if double bond possibility is not there, you have to add hydrogen. And the third rule is after completing this second process, still valency is left, you have to add double bond in the next segment. Okay, let us see how it will be working. So these three rules you have to keep in mind. So we are just moving in anti-clockwise direction. It is nothing but like this. Okay, so we are moving like this. Now this particular carbon, you can see that valency can be filled simply by adding double bond. So I'm just adding double bond between hydrogen and the carbon. Now let us take the case of nitrogen. Nitrogen is having 3 valency, so that is filled already, 2 with carbon of the first and then 1 with the another carbon. So it's filled, so there is no more addition of hydrogen there in the nitrogen. Now the third carbon, you can just see all the valency is filled because 2 with the oxygen. So this particular carbon, oxygen is filled, and then oxygen is filled with the 2 valency is filled, and then 1 with the nitrogen and the another one with the another nitrogen. So all the 4 valency is filled. Now take the case of nitrogen. This particular nitrogen, you can see that this nitrogen 1 valency is remaining and there is no possibility for double bond in the first position. So the second chance is add hydrogen. So we can just add hydrogen to the nitrogen. So the nitrogen valency is filled. Now we can just take the carbon that is here, and you can just fill with a double bond, but there is no more chance for the double bond in the first position with nitrogen because nitrogen valency is filled already. So the next chance is adding of hydrogen. Still after adding hydrogen, 1 more valency is remaining and we can just add a double bond. Still in the last carbon, you can see that 1 valency is remaining and that you can fill with the hydrogen. So there is a structure of cytosine. So rather than remembering the entire structure, you should understand the process by which you are forming the structure. And if you are understanding the process by which you are forming the structure, you can easily remember the structure. Now let us see, cytosine is undergoing deamination to form the uracil. So this particular amino group should be removed. So when that amino group is removed, the component that is added there is nothing but oxygen. So a double bond oxygen will be coming there. Now let us fulfill the valency. So there is no possibilities of double bond between nitrogen and carbon here. So the next chance is addition of hydrogen to the nitrogen. We are just filling the hydrogen to the nitrogen. Now the next carbon is, the double bond is already done. So all the 4 valency is filled. So there is no chance for addition of anything. Now the nitrogen part, the second nitrogen. So there is 1 valency is remaining. So in the first part, there is no chance for the double bond because the carbon valency is already filled. So we are just adding 1 hydrogen. Now to the next carbon, the same process that we have repeated for the cytosine. The cytosine we have done will be repeated here. So first hydrogen is added, then double bond is added, and then hydrogen is added. So this is the structure of uracil. And we know that uracil is undergoing methylation process to form the thymine. So we can just think of at which position the methyl group is added. The methyl group is added in this particular position. You can just remember in this position the methyl group is added. So you don't have to bother about any other part except that position. All the structures will be same like uracil. So I'm just adding everything like uracil except at that particular carbon, and we can just add methyl group at that particular carbon. So that is the structure of thymine. So this is the way by which you can easily remember the structures of cytosine, uracil and thymine and the atoms or molecules distribution in the ring structure of pyrimidines. Okay, rather than remembering the structures, you can just remember the processes by which the structures are formed. That is the easy way to remember. Now we are just moving into purine case. Okay, so purine, I'm sorry for this pyrimidine. So this actually mean for the purine. So purine remembering is easy. You have to remember only amino adenine, because we know that purines are of two types, adenine and guanine. So only one confusion is remaining there, which purine contains amino group, whether adenine or guanine. It's easy to remember because adenine contain A, which is there in amino. So amino adenine, that is the only thing that you have to remember with regard to the structure of purine. So please remember, read this as the purine, not pyrimidine. So let us see. So adenine and guanine. So there is a, just like pyrimidine, we have already learned one basic structure. Adenine is also having a basic structure which is double ring structure, and the basic structure is this. You have to remember this structure, the basic structure you have to remember. There is no other way. And now let us see how can we distribute the atoms or molecules in adenine and guanine. As we already told, amino adenine, we have to keep in mind that adenine contains amino group on top. So we have wrote amino group on top. Now let us fulfill the valency in the way that we have done for the pyrimidines. So double bond here, then hydrogen there, and then double bond there, and double bond here, and then hydrogen there on the nitrogen, then hydrogen on the carbon. Still carbon valence is not filled, so double bond we are just adding. So that's the structure of adenine. Okay, so easy to remember, there is no confusion. We are just filling always in anti-clockwise direction. We have to prefer double bonding first. If double bonding is not there, you have to add hydrogen. Even after adding hydrogen, if valence is not filled, you have to add double bond in the second position. Okay, so let us see the guanine. So guanine doesn't contain amino group on top. Instead, it contains amino group at this particular site. So think about the situation. If you are moving away from your mother, you will be just reaching to your father. In the same way, if the amino group is moving away from this particular carbon, it will be moving to the nearest carbon. So that is nothing but here. So let us see, instead of amino group, there will be double bond oxygen there on top. Then we have to fill the valency. You can see that the nitrogen valency is not fulfilled. So we can just add hydrogen, and you have to keep in mind that the amino group that is left from this particular carbon is reaching at this particular point. Now we are just filling the remaining valency, double bond between the region, and then double bond there, and then hydrogen, and then again hydrogen, and a double bond. So that's about the structure of adenine and guanine. So it's easy to remember, only one keyword is there, amino adenine, and for the pyrimidines there is only one keyword, that is cut, and the thing is you have to remember the basic structure. So let us see how this idea will be working for you during examination. For that purpose, consider the question, which among the following is uracil? So these are the four options. Now let us see how we will be going to the answer. I will be moving to the answer. So first you have to remember that uracil is there in the keyword CYP. Adenine and guanine is there in the keyword APUG. So CYP. So uracil belongs to pyrimidine. The second thing is, we know that as pyrimidine name is long, only single ring will be there. So as a result, we can just avoid option A. So option A is wrong. Now the third thing is, remember cut. That means cytosine is converted to uracil and uracil is then converted into thymine. Cytosine is converted to uracil by the process of deamination and uracil is converted to thymine by the process of methylation. So we can see that the cytosine contain amino group because deamination is happening to that molecule, and thymine contains methylation because it is a methylated product of uracil. So we can just easily remember uracil is the one which doesn't contain amino group and methyl group. So we can just avoid option B and option C because option B contain amino group and option C contain the methyl group. So our answer is D. So the option D is the answer. So this is the way how can you find out the answer during competitive examinations. Okay, now we are just moving into the university examination, that means descriptive examinations. The question appearing normally is, draw the structure of purine, draw the structure of pyrimidine, draw the structure of adenine in that way. Okay, so let us see, I am just considering the question, draw the structure of adenine. So we can see that, remember APUG, that means adenine belongs to purine. So remember APUG and CYP, pyrimidine contains cytosine, thymine, uracil. APUG, purine are nothing but adenine and guanine. So adenine belongs to purine. Purine name is less, so it is having 2 ring. So purine name is very short, so it's having 2 ring. So we have to draw the basic 2 ring structure of purines. Now you have to remember amino adenine, that indicates adenine contains amino group on top. Okay, so we can just draw the amino group on top. Now there is nothing left, you have to fill the valency in the way that I have mentioned. First double bond, if not possible hydrogen, if then valency is remaining, add a double bond in the next session. So let us see double bond. Okay, so fill the valency and you can just complete the structure of adenine. So we can just do double bond there and then hydrogen there, then double bond, hydrogen, again hydrogen, double bond. So that is the structure of adenine. So we can easily draw the structure of adenine, guanine or purine if you are remembering the keywords. I am just keeping in mind to avoid confusion which are the purines, which are pyrimidine. You have to use the keyword APUG and CYP, that means cytosine, thymine, uracil are pyrimidines and adenine and guanine are purines. In order to avoid which purine or pyrimidine contains 2 ring, you have to remember purine is having less letters, therefore more ring. Pyrimidine is having more letters and therefore less ring. So pyrimidine is having single ring and purine is having double ring. And the last thing that you have to keep in mind is the distribution of that particular ring structure. So in case of the pyrimidine, you have to keep in mind cut. Cut means cytosine, uracil, thymine. Cytosine is converted to uracil by deamination. Uracil is converted to thymine by methylation. So that thing you have to remember. In case of the purines, we have to remember amino adenine because adenine top part contains amino group. So these are the ways you have to keep in mind by which you can just avoid confusions and you can easily draw the structure and you can easily remember the names of purines and pyrimidines. Hope the video is helpful. You have to keep in mind that this is important for the NEET to NET examination as well as for many PG level entrance examinations. And I'm just adding the point that if you did not subscribe the channel yet, you have to subscribe, and also you can just click on the bell button to get notification. And I'm just seeking your suggestion. You can just suggest the topic that I have to take. You can just suggest it on the comment box. Also, one more thing, if you need any Malayalam description, the same PPT presentation with the Malayalam description, you can also just comment in the comment box. I will be preparing with the Malayalam description and we will be just uploading it. So that is the end of the video, and thank you for watching. Thank you so much.